Okay, talking about 11.2, right? And we are talking about, I think I kind of ran through our different sampling methods. Okay, we're getting ready to work on using these. So we talked about simple random sample, just basic random. Stratified, which is dividing into groups and then picking from each group. Cluster, dividing into convenient clusters, picking an entire cluster. Systematic, that's every umpteenth person, okay? And then convenience, picking out convenience, okay? Not going to any effort to randomize or anything. Self-selected, you get to choose whether you respond. Okay, so we're going to go down and look at what sampling method is used in each of the following examples. And then also, is the method likely to be biased? So talking a little bit about how much bias is likely to be seen there. So A, starting with a randomly chosen ID number. Every fifth student ID number was chosen, and that student was asked to fill out a survey. So you have the list in front of you. Scan through. Which type of sampling do you see this being? Toph? Systematic? Okay. This one, they say every fifth student ID number was chosen, yes? So when it's, again, my, generalization was every umpteenth, person or whatever, this is systematic sampling. There is a system to it. What about bias? Is there likely to be bias here or not? No. Okay. The idea is this is a random design. Okay. This is designed to be random, and so it is designed to be what I'm going to call unbiased. Okay. B. A retailer put feedback cards at the front of its store. They got responses from 22% of their customers. Self-selected sample? Because does everyone have to do this? No. Just people that have interest are going to take the time to do this, right? So it is self-selected. You pick whether you respond or not. Thoughts about bias here?
No.
Biased. You pick whether you respond or not. Basically, you're picking if you care to respond or not, aren't you? Okay. Generally speaking, in this situation, I'm not saying always true, it's going to be the people with a strong opinion one way or the other that are going to respond. Okay. So how I have it written in my notes is that this is highly likely to be biased. And on all of these, we can't guarantee bias or unbiased, but, generally speaking, that's what we would expect there. Okay, C. A city wants to know what % of people in the city own a dog or a cat. A city worker goes door to door in the neighborhood around City Hall to ask people about their pets. Convenience, maybe? What?
Because it's a city official. They work in the City Hall. And they're going to the neighborhood near City Hall.
Okay. They didn't really go out of their way, did they? Okay. So, as she said, it's a city worker. They're going door to door around City Hall to ask people about their pets. One neighborhood, not necessarily, a mixed population there, right? And so, with that in mind, it might have more of a general same concept there. So, I would agree. Convenience sample. What about bias in this one?
Hard for it to be biased. Do you have a cat or do you not?
Okay.
But maybe the neighborhood around City Hall is wealthy, so they can afford to have more pets.
Okay. And this is a tough one because with convenience samples, I tend to think of them being more likely to be biased. However, in this scenario, I mean, even though it was convenience, he just went to, or the city worker just went door to door right there around City Hall, it was still random door to door, wasn't it? Okay. So this one, I don't know. I have written in my notes likely unbiased, but likely. Could there be some bias depending on the neighborhood? There could be. I'm not going to argue there couldn't. Okay. So you have to take into account the situation. Okay. The population is grouped according to age, and a random sample is chosen from each group. What are we thinking here? We're down to two choices, right, if we're going to play that game. So it's either stratified or clustered. What makes the difference here? Yeah, so population is grouped according to age. So, okay, they're put in groups of like, some type of like quality. But here's the key. A random sample is chosen from each group. Because of that, that makes it a stratified sample. Did I spell that right? Yeah, I guess so. Thoughts on bias? Okay. Yes, they grouped according to age, but then they picked someone, they picked from each age group, didn't they? Okay, so again, no guarantees, but most likely unbiased is how I have it phrased in my notes. Okay. Do me a favor and read the last one before you answer it. Okay. A number of hospitals around the country were randomly chosen. Within each hospital, all of the nurses were chosen. Okay. Well, I would say if we go with the rule of we only have one left, that puts us at cluster. Now, here's what we need to figure out. This cluster, let's make sure we understand this. Okay. With cluster, by definition, it's divided into convenient clusters, and the entire clusters are chosen at random to the sample. So they are talking about dividing up by hospitals, right? And they pick the entire cluster of nurses in this case. So cluster sampling. What about bias?
There can be some because they're all in the same hospital.
Right. And here's the thing. Probably depends what they're surveying them about, yes? I think that would make a big difference, okay? But could bias exist here? Because they picked all nurses, bias could exist, okay? So likely bias since only nurses. Now, again, give me the survey question, and I might have a different opinion, okay? But that would be generalization. So I'm going to say likely biased since only nurses or all nurses. Okay. If we're surveying something about what goes on in the hospital, nurses have one opinion. Doctors, administrative staff, desk staff, security staff, different people may have different opinions. So, okay. Back page. We need to do a little discussing here. But one of our standards is to be able to design a study, okay? To be able to think about ways to come up with groups or to make them random or whatever the case may be, okay? But to design a study. So we have two scenarios we're going to talk about. The first one is we're being asked to describe a design for a controlled experiment to test a new drug for treating the flu on mice. And then how does randomization apply to your design? So we just need some basics here. But we're trying to design a controlled experiment to test a new drug for treating the flu on mice.
Catch 1,000 mice randomly and test them all for flu, and the ones that have the flu, treat them with the drug.
How do we know if the drug works then or not? Or how well the drug works?
Well, then we see if we just watch to see if it works.
You have two sample groups.
I say, with that in mind, we're going to have two groups.
Also, should we keep the mice that don't have the flu and treat them too? And see if
No, keep sick ones and then treat some of the medicine, and if the sick ones are still sick, then they're sick, and if the ones that were sick aren't sick anymore.
Okay. So at this point, we need two groups of mice where both groups have the flu, but one group gets treated, one group doesn't get treated. Okay? Because then you are able to see how that drug responds on the mice that have the flu versus how the mice respond to the flu but without treatment. Okay? Now, are we going to randomly catch so many mice all with the flu?
no, we catch many mice and test them for the flu and release the ones that don't have it.
Or
Get one out.
it's science, so take a bunch of mice and give them the flu. Okay, kind of what a flu shot does in a way, right? It gives you a little bit of the flu. Okay, so yeah, we're gonna take a bunch of mice, put them in two groups. Everybody gets the flu. One group gets treatment. One group doesn't get treatment. Okay. When we talk about one group gets treatment, one group doesn't. You guys familiar with the vocabulary control group, experimental group? Okay. The control group is the group that just goes on with life. They get the flu, they fight it off. The experimental group is taking the experimental drug. Okay. So, okay, I have, let's see. I'm going to say randomly assign mice to two groups. Inflect, not the word I'm going for. Let's go with infect all mice with the flu. The good and bad of science, you can infect somebody with the flu. One group receives treatment, that's our experimental group. Other does not. One group receives treatment. Other does not. So the group receiving treatment is your experimental. I'm going to put that vocab in. The other group not receiving treatment is your control group. Okay. one other scenario here. Design an experiment to test whether drinking coffee improves memory. How will you choose the experimental and control groups?
You take a sample of people and you tell them something. And you have one group drink coffee for a week and the other group not drink coffee for a week. See who remembers what.
Well, some people are naturally gonna have better memories than each other.
Exactly, that's why the coffee drinking doesn't differ.
And yeah, and I do agree. You're going to have, you know, naturally, there's people that have better memories than people that don't.
Yeah.
But at that point, if we're looking at whether drinking improves memory, randomly assign the groups there.
Or you could like have them like do some like memory quiz before, and then the next week drink coffee and take like a different quiz.
Like some type of memory, yeah. However, and at the end, that's the thing. You're going to have to give some type of memory test. Don't ask me what that looks like or what that is, okay? But I don't know. I remember in elementary school, I can't remember what it was called, but it was a variation of, you know, iStep or iLearn or whatever. But where they would in one, I don't know if you guys have done this or not, but in one testing session, you'd go through like these random weird words, and then you'd go do some other test, and then you come back to that one later in the day.
They'll tell you like 3 words to remember, and then they'll do a bunch of other stuff. And they'll ask you, like,
Oh, yeah, I
remember those 3 words.
My list was much bigger than 3, but it was.
I think 3 is how they do the dementia Alzheimer's test. Yeah.
Okay. So, obviously we need 2 groups, yes? We need a group that doesn't drink coffee and a group that does drink coffee for this time period. So, control group and experimental group. And then somehow or another give some type of memory test. Okay. Some type of probably pre and post memory test, or give them information, test them afterwards. Some type of memory test, yes? Okay, so let's see. 2 groups. The control group is the group that gets no coffee. The experimental group gets to drink coffee. Okay. And then, you know, somehow or another, we're going to give memory test and compare results. Okay. You have some 11-2 homework to get working on. If I recall from what I saw, there's 16 questions. Okay, you're going to have some vocab going on. So work on, I'd say,